we have Bozhanov. He is going to talk about scaling horizontally AWS services. Please welcome the guy who is 15 on top Stack Overflow. He used to be 13, but now he's 15, so please welcome him.
Are we talking about scaling on AWS, doing highly available stuff on AWS? It will be a sort of a mid-level talk. I mean, I won't go into too many details because that would be boring for many people, and only a handful of Russian scientists could understand it. A little bit about me. I'm a senior software engineer and architect. I have experience in large companies, for example, TomTom, where my first actual encounter with highly available and highly scalable infrastructure on AWS was. I'm currently founder and CEO of Log Sentinel, which is my own company for doing secure audit trail using cryptography similar to blockchain. I have a blog, Twitter, and as the announcer mentioned, I used to be top 30 on Stack Overflow. Since I haven't been answering questions for a while now, I'm up to top 50 or something like that. So to begin with, let's answer the question, why would actually we need to scale? First, why do we need high availability? And high availability and scalability are related, though not obviously the same thing. You would want high availability practically almost always, because you don't want your service to die if one of your machines is dead, and machines die. The Bulgarian commercial register showed you that in recent times, but there are many, many more examples of that. If you rely on just a single machine or a single data center even for your infrastructure, you will go down. And this would mean losses for your business, for your service, etc. Why do you need scalability? And that was covered yesterday in a very nice and interesting talk. You'd need that to account for spikes, for increasing load over time, and in general, if you're a successful service and a company, you would probably need to scale. The good thing is, if you have a decent high availability, you're likely more easily scalable. Now, the two things are not equatable, but they're kind of related. But I would second the advice of yesterday's talk: do not over-design. Do not start with the hugely scalable infrastructure when you have 0 clients. Upgrade things along the way, but have in mind that you might eventually need to scale. And then, why AWS? Or for that matter, any cloud provider? Well, it's easy to get started. It's very little investment, so you don't have to buy a lot of hardware, bare metal, to actually have support for multiple data centers, because this is what AWS gives you out of the box. So initially, it's a kind of minimal investment. Now, obviously, if you become huge, it might be a good idea to move to your own infrastructure, but for the beginning, up until some time you're fine on AWS, it's actually a more cost-effective solution. Now, what AWS is, probably most of you know, but I'll still go through a few points. It's originally infrastructure as a service. You basically get a bunch of virtual machines that you can create through a web console or command line. You get some other nice things as well, like load balancers. Yesterday's talk covered a bit of how load balancing works on AWS. It is scalable load balancer, so if you get hit by incoming traffic, the load balancer scales automatically, so you don't have to care about that. There are security groups, things that you can configure the access to your instances, and so on and so forth. There are, with time, Amazon decided to build some platform as a services on top, like Beanstalk and others. The good thing, as I mentioned previously, is that you have multiple regions. You can choose to deploy your things in US, in the EU, in Asia, practically everywhere around the world now. And this is good because you just switch one drop-down, and you're in the different part of the world, closer to your clients, wherever they are. Each region has multiple availability zones. An availability zone could roughly be seen as a separate data center. Now, that's an estimate, but you could consider them as multiple data centers, and you could easily scale cross-availability zones without doing almost anything extra, and that's pretty good for your high availability. So even if one data center goes down, the connectivity gets shut down, there's an earthquake or whatever, then the other data centers are still up and your service is up and running. Cross-region scaling is a bit harder, but you can still do that. You can have your service running in the US and the EU and in Asia, and then have a single web domain pointing to your service. You could do that with, as mentioned yesterday, DNS round robin or other means. It's very specific, AWS, but it's also quite similar to other cloud providers in terms of the basic concepts that you're working with. It's similar to Azure, it's similar to Google Cloud, and that's kind of expected since the others more or less copied from AWS. Scaling your application, making your application scalable, is actually one of the most important things. And that was covered in detail yesterday. I'll just mention a few rules of thumb. Your application should be stateless. That's kind of an obvious thing, but many people forget that. No persistent state should be present on the application nodes. This allows you to scale your application nodes horizontally by just rolling up new machines. Now that's obviously simplified, but that's the basic idea. You could use caches, temporary files, stuff like that, that's okay. Sometimes you would want to have a distributed cache. AWS offers some options for that as well. Session state was mentioned yesterday in the Q&A session, and it's a very interesting thing because for web applications, you probably normally want to have a user session. Now, if you're just exposing an API, that's probably not the case, but in many cases, you need it. So there are two options for that. One is just using some sort of a distributed solution like a Redis or any distributed cache actually to store your session state. The other option is to have no session state or to serialize the session state to the client, for example, using JWT tokens. Now that's a design decision we won't go into, but it's an option for a highly scalable infrastructure to just not have a session state on your application nodes, that is. And obviously that following these rules makes your application layer scalable horizontally, and given that, you should have in mind that your application nodes are disposable. Do not look at your server and think that it's the thing that you should care about and not let it die under any circumstances. Think of your application nodes as something that can die. And sometimes on AWS and even on your own infrastructure, machine dies, virtual machine dies, bare metal machine die. So have that in mind and build your infrastructure around the fact that everything fails. Still staying on the application level, you sometimes would want to execute something only once in a cluster. Now, I mentioned that you should be able to just add virtual machines and scale horizontally, but sometimes your entire cluster should run something just once. And there are multiple ways to do that. Database back scheduled job management is one of them. There are scheduled job frameworks that are backed by a database, which is your centralized data store, and then they coordinate between them which instance should execute the particular job. It's sort of similar to a queue. Some queues have some deduplication capabilities that you might want to use for that, but it's I think, an over-design for just that thing. What I've been using recently is a pretty interesting solution. It's called Hazelcast. It's Java-specific, but it's pretty interesting anyway. It allows you to do distributed logs without using something like Consul. Consul obviously is another option. But Hazelcast is doing peer-to-peer communication, and it allows you to do distributed logs as well as some other distributed interesting stuff. Now on to scaling. AWS offers you the so-called auto-scaling groups. They're groups of virtual machines, which are, in AWS terms, are called instances. And they are machines with identical configuration. So an auto-scaling group is just a number of machines, and this number is defined either manually by you by setting it to 3 or 4, or you can define scale up and scale down rules. So if for the past 5 minutes your CPU utilization for all of the machines was over 80%, this means that you should probably spin another one to handle the load. This could not be CPU utilization, it could be disk I/O, could be network input and output, I think any criteria, or you can have combined criteria as well. Scale down is also interesting because when you handle spikes, it's good to have your new machines created, but then the spikes die. your marketing campaign is over, your front page on Hacker News post gets moved to second or third page. So these machines that were created probably need to go down because you don't want to pay for them. And then you could configure scale down criteria. So if CPU utilization falls under 20%, then destroy a machine. And now this gives you a glimpse of why you should consider your application nodes disposable, because you should be able to throw them out at any point and still your cluster should continue running without any problems. There's a very interesting thing called spot instance on AWS, and it allows you to not only to scale, but also to do some very heavy and probably CPU-intensive jobs in the background. Training models, machine learning models is one of them, but there are all sorts of applications like running big suites of tests, either performance tests or functional tests, whatever. And they're pretty cheap. They can go as cheap as with a 90% discount from an actual virtual machine. The catch is that you bid for them. And as soon as you're outbid, AWS just reclaims their machine. They snatch it from your hands and your processes die. Obviously, you could reserve it for 1 hour periods. It gets a little bit more expensive in that case. But the point is that if you need to run something that you don't necessarily care that should be always completed with success, you could rerun it later, then spot instances are a good thing to consider. Now, data stores is one of the most interesting things about scaling, because this is where state lives. And AWS offers a bunch of options for the data store. There are managed data stores. These are the relational database data stores. AWS calls them RDS. And you can get a managed installation of MySQL, of MariaDB, of Postgres, of Oracle, of MS SQL. AWS also offers you search engine, Elasticsearch, and also caches. You could choose between Redis and Memcached. And the good thing about that is you don't have to install the thing, to keep it up to date, to configure it. It gets managed by AWS. You just consume it either via ODBC, JDBC, or whatever your programming language is for the databases, or through RESTful APIs, for example, for Elasticsearch. There are also custom-built AWS data stores. Amazon Aurora is their relational database. There's Cloud Search, which is a search engine written by Amazon. It's not exactly Elasticsearch. And there are also some key value stores like S3, SimpleDB, and Dynamo. S3 is a key value store. It looks like a big shared file system. Underneath, it's actually a key value store, and it's pretty interesting how they scale it. You could obviously have your own installations. Just spin a few virtual machines, install anything you like. We are using Cassandra, for example, at the moment, but you could deploy any database as if it's you have to configure it, you have to keep it up to date, do the backups, etc. Scaling data stores is obviously the hard thing. I mean, this deserves a talk on its own, so we won't go into too many details here. The custom ones are automatically scaled. S3, you don't have to do anything. It's cross-region. You could put things from anywhere, and you could retrieve things from anywhere. You obviously cannot use it as your primary data store because it's kind of expensive for that. You pay per 1,000 requests or something. But it's pretty easily scaled because AWS handles that for you. They did the heavy lifting. The managed ones are scaled by configuration, meaning that you could just increase a few numbers in the UI, and a few other machines will be created. Now, obviously, that's not enough because the data has to be somehow resharded, which is, in many cases, your job, again. And own deployments are scaled via auto-scaling groups. So you deploy 2 Cassandra nodes, then you need more. So you configure your auto-scaling group to create new machines, identical to the previous ones that are connected to the same cluster, and then you have 4 Cassandra machines, for example. Now, how do you spread the data? Sharding, as mentioned yesterday, is one of the primary ways to do that. Sharding is defining some criteria how data is split among instances. And the sharding logic should be handled normally by the application or some layer in between. that knows this logic. Now, sharding by ID, for example, is kind of an obvious thing, but could also be sharded by location. Some users from Europe go to this shard, users from the US go to that shard, or there could be many other ways of sharding. You could also use some NoSQL data store like Cassandra to shard, to replicate your data using consistent hashing. So when you add new instances to Cassandra, it can automatically reshuffle how it stores the replicas of your data. Now that's a very good thing about Cassandra. It's not that trivial, obviously, to configure it, but it's a pretty good way to approach the data store and scaling it. And now we go to the Elastic Load Balancer. Now AWS provides that, and it's a black box of sorts. You don't have too much control over it, apart from few configurations. And it can point to a specific auto-scaling group. Now, it's called target groups because they introduced some version 2 load balancing, but anyway, imagine that these auto-scaling groups that I was talking about, a bunch of identical machines serving content, you could put a load balancer in front of them and say, okay, any request that comes to the load balancer goes to one of these machines, either in a round-robin fashion, or I think the newer versions have some additional rules for that. Speaking of load balancing, you could choose to have the so-called sticky session if you want to not replicate your session, but also don't want to store it in a distributed way. You could have a sticky session from the load balancer. So the load balancer keeps the data of which user has access to which instance. Now that's not always a good solution, but it's an option that you can review. You can configure anything, the protocols, the ports, the health check endpoint, so the load balancer should know which instances are healthy and which not, so that it can forward traffic to them. So if one of your nodes in the auto-scaling group dies, the load balancer should not obviously forward traffic to it. So you could define custom health check endpoint that check if the machine is healthy. And if it's not, then load balancer doesn't forward traffic to it anymore. You could monitor the load balancer. You can do TLS termination. Now, you can configure AWS actually managed certificates. They have a pretty easy UI even for creating certificates. And then you just say the load balancer handles TLS termination, and it forwards back to your machines using plain text HTTP. And that offloads a little bit from your machines because the load balancer handles the TLS handshakes. It's not always a good idea to terminate the TLS on the load balancer, but in many cases it is. Now, load balancer is usually seen as something to put in front of your application nodes, the thing that serve the users, the thing that print the UI. However, you could use them for any kind of part of your infrastructure, for example, the database. You can put a load balancer in front of the database and then just connect, rather than connecting to a particular server from the auto-scaling group of the data store, but just connect to a single endpoint for the data store, and then the load balancer will choose one of your database instances based on the most often round-robin criteria. Obviously, as it supports TCP, you can do that. It's not only an HTTP load balancer, because many databases actually don't work on HTTP. They have some TCP protocol, and you could do that. So there should be things that you should automate in this case. I mean, I've been talking about auto-scaling groups, about things, about replicable configuration. And there are a bunch of things that you can automate in this process so that you're not clicking manually here and there to create all of these resources, to configure them, and then forget what actually you have configured previously. What you could automate is obviously the hardware and network resources. So what machines, what type of machines, what type of load balancing, the security groups, etc. You could automate the application and database configuration provisioning. So your instances, both your application nodes and your database nodes, what configuration they're using. And you could also automate the instances themselves, so what type of software they support, what version of the software, etc. So my favorite thing actually about AWS is the ability to do scripted stacks. Now, all of that thing that consists of your database instances, of your application nodes, of load balancers here and there, of message queue nodes, for example, anything, can be scripted. You can create a file or multiple files that describe all of the resources that you need, your hardware resources and network resources for your stack. And you obviously can create those manually. I mean, AWS has a pretty good, sort of good web console where you can just go and say, create instance, and then create auto-scaling group, or create load balancer. But doing that manually is not replicable. I mean, you cannot replicate that the next time. You have to write it down somewhere. We do this and this. You won't be able to launch identical stacks for testing, etc. CloudFormation allows you to do that. CloudFormation is this automating stack creation and update on AWS. It's a sort of a scripting language, mostly descriptive language, but also has some scripting elements. It's either JSON or YAML. Now, doing code in JSON is kind of ugly sometimes. And these files tend to get pretty big, so it's not the ideal solution, but it's pretty readable in the end, and I'll show you some examples after that. The good thing is that CloudFormation manages updates. So you describe your stack, you say, I want to have 2 auto-scaling groups, one for my application nodes, one for my database, or one for my message queues. Then I want to have 2 load balancers. Then I want to have the security groups configured so that only these and these ports are open. And also these are my health checks, these are my Elasticsearch nodes. You describe everything. And then you figure out, okay, I need another auto-scaling group. And so you update your JSON file with another auto-scaling group. You update your stack, and AWS creates just the new auto-scaling group. You don't have to recreate the whole thing and bring your production system down. Everything can be parameterized, so what kind of machines you want. Do you want smaller machines? Do you want bigger machines? The number of nodes in each auto-scaling group. What domains you use, S3 buckets, everything is configurable, and you could change that configuration again by updating your stack, and you don't have to recreate it every time you change some configuration of your stack. Now, this is how a small part of a CloudFormation script looks like. For example, this is a database launch configuration. A launch configuration describes your machine, a single machine within an auto-scaling group. And obviously, since they are identical, all of your machines in your database auto-scaling group should look like that. And there are tons of options, obviously. You could choose to associate public IP addresses, or you can choose not to. There are some other profiles. You can have an image ID. So all of your instances can be based off a particular image. And AWS offers you a bunch of those, but you can create a custom one. It will be OK. What's the instance type? Do you want an XX large instance for your database? Probably. Or you have just a T2 small for your testing environment. So with this with this script, you can create a huge production stack with big machines and a smaller staging stack. It will be identical except for the types of machines that you use. And you could obviously configure security groups, meaning which ports are open, which ports are not open. This is another example. It's a load balancer. It is, in this case, internet-facing. So this is the public one for your application nodes. And notice here that you can configure some subnets. I've been mentioning you could manage your network in a way. And these are subnets. And in our case, these subnets represent different availability zones. So your load balancer works in all the 3 availability zones in the particular region so that it can forward traffic to all data centers, basically. And even if one of them dies, you're still fine. Again, security group configurations. Security is important, obviously. This is a target group, the thing that says where your load balancer points to. And again, you can see all sorts of very useful configurations. So which is the health check? Which is the protocol that you want to forward? Did you terminate the TLS on the load balancer, or didn't you terminate it? So if you did, then obviously use HTTP to forward to the application nodes. The health check interval, the health check endpoint, what status code you expect from the health check, the port that you want to forward to your instances. You see 8080 rather than 80 simply. The registration delay, so how long should load balancer wait before deregistering the instance that it considers unhealthy, and so on and so forth. So again, why CloudFormation? Well, it allows you to replicate stacks. It can be used for different customers. You may be offering your service to multiple customers, and you want to deploy a stack for each of them. So you just grab your stack.json and create an exact or quite similar stack for each of your customers. It can be used for different environments, as I said, production versus staging versus test versus anything. And it could be used for disaster recovery. I mean, if something completely and horribly dies, you could launch up a new stack in a few minutes. Then, of course, restore your backup if you can, and you're up with a little bit of downtime. It also means that you have a clear documentation of your infrastructure. If your infrastructure is only what is described in your CloudFormation script, then this means that this is the entire documentation of your stack, which is pretty good. It's DevOps friendly. In both cases where I've used CloudFormation, which is in TomTom and in my current company, we don't have any operations. I mean, TomTom is a huge company, and the developers were the ones that were doing the operations work. And this one makes it very, very friendly. It's not that hard to learn. The drawback is that they're slow, the change in test life cycles. I mean, you're creating actual machines, virtual machines, but still. So if you want to deploy a new stack and then try changing things, something breaks and then you try again, it could take a day because bringing up and taking down stacks takes more than just a click of a button. And the problem is that it's proprietary. So you cannot use that outside of AWS. There are alternatives like Terraform, which allows you to do practically the same thing with a more generic language or of sorts. But the thing is, you're still tied to a couple of native AWS concepts, like the autoscaling groups, the EOBs, the security groups, etc. So even if you do a cloud agnostic solution, you still be tied to a bunch of concepts from that cloud provider. The other thing that can be automated is the configuration provisioning. AWS offers you OpsWorks, which is a hosted version of either Puppet or Chef. And I won't be going into details of how you use Puppet or Chef, but they are kind of a standard thing now in the industry. You could use Capistrano to simply log into all of your instances and execute X, Y, Z, whatever you want. Or you can do a very simple thing that I've been doing. You could have your configuration on S3. This is the shared data store that every instance has access to. And you put your configuration there, and then on load, your instance launch configuration has that configured, where to fetch the configuration from. And on creating the instance, it gets the configuration, and all of your instances are thus configured identically. Now, this means that in order to change the configuration, you have to kill the machine and restart it, rather than just restart a certain process. But you can actually combine these two approaches. So on startup, fetch from S3, get everything running. If you want to change something, for example, use Capistrano. It's an option, and we've been using this hybrid approach. CloudFormation can write dynamic values to these configuration files. So because your stack is dynamically created, some of the resources don't have a fixed name or domain names, like the load balancer for the database. This is why, here another example of CloudFormation, you see you can write anything to your application properties file that you have recently fetched from S3, for example, the database host. And the database host could be equal to a reference to the database EOB address. It's a CNAME, an internal CNAME for the AWS infrastructure, but you can see that this can be dynamically configured. And another thing is the automated instance setup. Obviously, you could use Docker. AWS offers an abstraction on top of Docker. It's called Elastic Container Service, and you can choose to deploy Docker containers on specific EC2 instances that you have specified and that you have already spin up. Fargate is sort of a subservice of Elastic Container Service, where you don't need to know about EC2 instances at all. You just say, I want these Docker images to be deployed to a number of times, and then Fargate handles the creation of the underlying infrastructure for you. It's not that flexible as handling it yourself. Obviously, it's easier. We have to mention Kubernetes. Disclaimer, I haven't used it. It is vendor independent, but as mentioned many times, don't over-engineer. So if you are just starting, obviously you don't need to configure the huge Kubernetes cluster, or even Docker for that matter. If you don't do microservices, then probably Docker isn't the best approach because you could just spin virtual machines rather than Docker instances. You can automate your machines by using Packer, which is another tool by the same company that does Terraform. And it creates images of your virtual machines. And then you can reuse those images by uploading them to AWS. And in that configuration of the image ID, you just specify the image and you have a replicable, identical images for your application nodes or database nodes or whatever. And obviously, as usual, you can do that manually. On your launch configuration, in addition to the configuration files, you could fetch a shell script from S3. A shell script that you have configured. You fetch that and then you execute it and it updates your current, whether you're using Ubuntu or CentOS, doesn't matter. It gets your dependencies, it configures your services, it starts them up, and that works. It's pretty straightforward and simple, and that's okay. If, again, something changes in that, you destroy the instance, you create a new one, and it works. The very, very important thing about scaling and about high availability is how to do zero downtime deployments. So you have these machines and you want to create a new version. How do you do that? Well, there are obviously many ways to do that. My favorite being the blue-green deployment. So you have two identical, in our case, could be auto-scaling groups. One of the auto-scaling groups is the current running one. It serves all of your requests. And the other one is idle. It has 0 instances. It doesn't cost anything. It's just staying there, ready for a release. Now you create 2 folders on S3. One of them is called green. The other one is called blue. And you put your releases sequentially. First in the green, then in the blue folder, then again in the green, then again in the blue. The important thing about blue-green deployment is that you still have a shared database. So the database layer stays the same. The 2 auto-scaling groups are connected to the same database. So when you do a new release, you open the standing idle auto-scaling group and say, okay, now spawn some instances, for example, 2. It creates 2 instances. It launches the configuration, gets the configuration files, executes the setup scripts, or installs the Docker images, etc. And then you have 2 identical in terms of infrastructure stacks, but one of them has your new version. Now, it doesn't accept any traffic yet because you haven't pointed anything to it yet. But this auto-scaling group has its own load balancer. You can execute some acceptance tests against the newly launched version of your application to see if everything's working. And if it does, you simply switch the DNS record from the existing running auto-scaling group, its load balancer, to the newly spawned one. And that way, some of your traffic will eventually, all of your traffic will eventually go to the new one. At some point, someone who has cached DNS records, etc., will go to the old one. But eventually, all of that will be pointed to the new one, and then you can shut down all the instances in the old group, and you have a zero downtime deployment. Now, it's not that easy always, because in some cases, they are breaking database changes. So one of the versions cannot work at the same time with the other version, and you certainly have a point where even if you switch the DNS record, some traffic will go to the old one and could break things. So there's this colloquially called the turquoise deployment. So you make an intermediate between the blue and the green that allows you to control these breaking database changes. So you prepare the database in the turquoise release and then do the actual deployment. It happens rarely, but it's worth checking out. And all of these steps can actually be automated via AWS command lines or APIs. You can do them manually. They're not that many. I mean, increase number of machines in the auto-scaling group, change the DNS record. But you can still automate that to execute tests, to check the results, and only then do the switch. In the end, some other very useful AWS services that are or are not related to scaling. IAM is the user and role management solution, and it makes things that you don't need passwords. You don't need to configure anything for your AWS communication with AWS APIs. Normally, if you're an external service, you would need API keys or secrets or stuff like that. IAM handles that if you are executing commands against AWS APIs from an AWS machine, that is handled for you. S3, as I mentioned before, it's a distributed storage, key value storage, universally applicable. You can normally store any file there, but you could also use it as a key value store. There's CloudTrail, and this is a very important thing. Your infrastructure changes, and destroying a machine, creating a machine, changing IAM roles, deleting S3 buckets, all of these things should leave a trace. And since I'm in the audit trail business myself, I appreciate how AWS did that, and they did that properly, almost, because not only they're providing you a log of all these changes, but also they sign that log, they timestamp it, so that your admin cannot modify the data in the log, which is a very important thing. There's also CloudWatch, which allows you to monitor all of your infrastructure based on multiple metrics. Everything that you can think of, you can configure it and watch it with CloudWatch. KMS is another very important service. It's a key management service so that you can encrypt your configuration, your secrets, or anything within your application with a key that is managed by Amazon in a secure way, for example, like an HSM. It's not the private key is properly protected rather than being stored somewhere accessible to admins. I mean, your admins cannot access the KMS key. They can only make it sign things, but cannot extract it and put it somewhere else. Glacier gives you code storage, and Lambda gives you the so-called famous and fancy serverless architecture, where you just execute some functions in the cloud. Now, this can be useful for scaling, because in some cases you don't need much of a storage. You just need to execute some CPU-heavy operations. And so you can create your Lambda functions and execute them via a RESTful service, and that might solve your problem. Obviously, serverless is not applicable to everything, but it's a useful tool again. And some general best practices. You have security groups, and you should only open ports that you need. This is kind of an obvious thing, but still, do not open any ports that you do not need. The good thing is that security groups by default everything is closed. So you have to go and punch holes here and there to make things work. It's a bit tricky in the beginning because things don't work. Some services expect ports to be open, not only the ones that you connect to, but some other ports. For example, Cassandra needs some gossiping ports between the nodes. And you start Cassandra and figure out that, okay, my cluster isn't working. Why? Well, because I haven't opened this and this and this port. It's a bit tricky, but it's a good practice. You may want to have a bastion host. So all of your instances, resources, auto-scaling groups should be hidden behind this single entry point, where you SSH to it, and from it you SSH to all of your other instances. You want to limit the exposure of your infrastructure to external attacks, for example. VPC, it's your virtual private cloud, your own network inside the AWS network. You can define subnets. It's a private address space, basically, so you're as if you're running your own infrastructure. It's a recommended thing to do, and it's pretty easy. You just say, I want a VPC, and put all of my instances into my VPC, done. And for authenticating to the AWS service, use multi-factor authentication, because if anyone gets your credentials, he can destroy your entire infrastructure, obviously. And as a conclusion, scalability is a function of your application. I mean, you cannot scale an unscalable application no matter how many auto-scaling groups you create. That's an obvious thing. But it's also dependent on your infrastructure. So if your infrastructure can't scale, then you have a hard time, obviously, scaling. When the load hits you, you won't be able to service it, and you have to spend a lot of time creating new servers. They will be not identical to the previous ones. There will be some mistakes, errors. We've all seen that. It's not a good thing. AWS is pretty straightforward to learn. All of that thing that I've been describing, by trying, you can learn it for less than a month, I think, so that's pretty good. And as I mentioned before, you can have a scalable infrastructure without much investment. I mean, you can have all of that and still run some small instances. One load balancer, 2 application nodes, 2 database nodes. That's pretty cheap. New services appear often, so check them out. There is an inevitable vendor lock-in. It's a Amazon infrastructure, so you're locked into that if you're using too much of their services. But if something can be done without AWS, then probably you can prefer that. And finally, Bash is inevitable. No matter how automated your infrastructure is, no matter how much Docker you use or whatever, Bash will always be something that you have to write, so get used to that. Thank you.